Okay, so we're going to do some modeling with quadratics, which is another name for quadratic word problems, but nobody likes the word problem, so I'm going to say modeling because it sounds better, but it's not. Okay, so I can model and solve problems using quadratics. Okay, so pause the video and read this as quickly as you can in 1, 2, 3. Alright, so it's talking about the width of the rectangle is 6 meters less than its length. If the area of the rectangle is 112, we want to find the dimensions of the rectangle. So first off, we are definitely talking about area, and area is length times width. So I'm going to do length and width. So notice the width is the one that you got a bunch of stuff talking about. So length is the easy one. Length I'm going to use as x. Okay? And then for width, it says the width is 6 meters less than the length. We already said the length was x, and 6 meters less is going to be x minus 6. Okay, so now we actually have enough information. So the area is 112. The length is x, and the width is x minus 6. So this is actually going to be a quadratic. What I'm going to do is I'm going to distribute the x to everything over here. So I have 112 equals an x times an x is an x squared, and x times a negative 6 is a negative 6x. Anytime we're dealing with quadratics, I want them to equal 0, so I'm going to move the 112 over to the other side. So my quadratic actually looks like this. And we've already learned multiple ways to solve quadratics. We could factor this, we could graph it, we could use the quadratic formula. Now, I'm going to let you pause the video and use whatever method of choice you want, but I'm just going to go ahead and tell you that I'm going to graph it in Desmos because I think it's so much faster. So, you pause the video and try to answer the problem in 1, 2, 3. Okay, so I graphed it. You may have to zoom out a little bit so that you can see it definitely hits the x-axis twice. So let's talk about this one. X equals negative 8. That means the length is going to be negative 8. So you're talking about like a real world problem, so a negative answer doesn't really make sense. So we're only going to focus on the positive one. So remember that we said, let's see, the length was x. Length was equal to x. So we know that the length is now 14, and we also said that the width was equal to x minus 6. So 14 minus 6 is 8. So the dimensions are going to be 14 by 8. Alright, so hopefully that made sense. Just using Desmos makes life so much easier. Okay. You can read this one. So pause the video until you've read it all. If you haven't, sorry. Okay, so the height of a rectangular prism is 3 feet. The length can be expressed as x minus 1. The width can be expressed as x plus 2. The volume of the prism is 198 feet cubed, and we want to find the value of x. Okay. So, first of all, it tells us we're talking about volume, and if you don't remember, volume of a prism is length times width times height. So, we're going to just start plugging in stuff. So, my volume is 198. My length can be represented as x minus 1. My width can be represented as x plus 4. And then my height is represented as 3. Okay, I'm going to show y'all a shortcut, and I usually wouldn't show people, but I'm going to. You don't even have to simplify this. You can type this entire thing into Desmos and get the answer. So I want you to pause the video, and I want you to type that into Desmos and see if you can find where it hits the x-axis. So pause the video in 1, 2, 3. Okay, so when you put it in Desmos, you get two answers. X equals negative 10, and you also get x equals 7. So the negative 10 doesn't make sense because we're talking about a real world problem, but my answer is x equals 7. Okay, so I showed you the easy way to do it, but now I'm going to show you the math way because I'm going to bet that some of you are going to want to go further in math, like into the pre-calcs and calculuses, and you'll have to know how to do this stuff. So first thing we're going to do is whenever you are multiplying, you can only multiply two things at once. So I'm going to start out with doing the x minus 1 and the x plus 4. And you can use the FOIL method. I just hate saying that because it's the distributive property, but that's what we're doing. So when I multiply an x times an x, I get an x squared. When I multiply an x times a 4, I get 4x. When I multiply a negative 1 times an x, I get negative 1x. And when I multiply a negative 1 times a 4, I get negative 4. So I have two like terms. 4x minus 1x is 3x. So here's what I have. Okay, this is going to go back in parentheses because I haven't done anything with that 3. Okay, so now I'm going to distribute 3 to everything. So I got 3x squared plus 9x minus 12. Remember that this entire thing equals 198. Because we're talking about a quadratic, I don't want it to equal 198. I want it to equal 0. So I'm going to subtract 198 to the other side. So I finally get 3x squared equal to 0 plus 9x minus 210. So now I would take this quadratic and I would solve it by either graphing it, factoring it, or using the quadratic formula. We already know the answer, so I'm not going to spend too much time on it, but if you wanted to practice using the quadratic formula, you solving by graphing, solving by factoring, you could, but you know the answer already. It's 7. Okay, go ahead and read this one. This one's a little confusing. Okay, this one's kind of weird. So we want to find two consecutive, which means right beside each other, positive odd integers, like 1 and 3 would be consecutive odd integers. 3 and 5, 5 and 7, stuff like that. Such that the square of the smaller integer added to 3 times the larger integer is 24. Now, I know that sounds crazy. So I want you to take a minute, pause the video, and see if you can come up with how you would express this as an algebraic expression. Like something's going to be x, something's going to be using a square, obviously going to have a plus 3 times. Okay, so just take a minute and see if you can figure it out, and then we'll talk about it. So just try. Okay, so here's what I want you to think about. If I say that my small integer is x, the only way I could get to the next consecutive odd integer would be to add 2. Like for instance, if I said 1 is my first integer, the next consecutive odd integer would be 3. The only way to get from 1 to 3 is to add 2. Okay, so hopefully that makes sense. Okay, now I'm going to have to use the fact that the square of the smaller integer added 3 times the larger is 24. Okay, so we're just going to read from left to right. The square of the smaller integer. The smaller integer is x, and if I square it, it's just x squared. Added to 3 times the larger integer. Is, anytime you see the word is in math, equals 24. So see if that makes sense. So we said the small integer was x, we said the larger integer had to be x plus 2, and then we just read the sentence. The square of the smaller integer, x squared, added plus 3 times, so 3 parentheses, the larger integer, x plus 2, is 24, equals 24. Okay. So I showed you already how you can put this into Desmos. So go ahead and do that and focus on the positive place it hits the x-axis. And you can pause the video in 1, 2, 3. Okay, I didn't screenshot it, but when you type this in Desmos, like I'm assuming that you're doing, because that's how you learn, it hits at -6 and it hits at +3. So we're going to use the positive one. So that means that 3 is the smaller integer, and if I do 3 plus 2, that gives me the larger integer. So my two integers were 3 and 5, and you just want to check to make sure that they make sense. So those are two consecutive positive odd integers. They're both odd, and they're both right beside each other as odd integers. the square of the smaller, so 3 squared, added to 3 times the larger is 24, and let's just make sure that that makes sense. So 3 squared is 9, 3 times 5 is 15, 9 plus 15 is 24. So if you have trouble writing the algebraic expressions, if this were a multiple choice answer, you could at least see answer choice 3 and 5, and you could do this stuff and see if it actually works out. So don't get discouraged if you can't do it the math way to do it, but maybe you could use the answer choices to figure out the problem. Okay, another thing that they love to do is called projectile motion. So kicking a soccer ball is a big one. So go ahead and read this and see if you can figure out what we're trying to find. And I'm going to pause the video. 1, 2, 3. Okay, so we kick a soccer ball off the ground. Obviously, we have a thing called gravity, so it's going to come back down. That's how you're getting the parabola shape. Okay, it tells us that we have an initial velocity of 90 feet per second. This is just superfluous information because it's in the equation. So if you look at the equation, you're given this. Anytime you see that -16, that's always talking about the gravitational constant. So if you go into physics, you'll see this a lot more. But usually anytime we're doing quadratics and we're talking about like something being thrown through the air, you're going to see that number. Okay, so it even tells us that our height is h, which is the same thing as our y-coordinate. Alright, and it tells us that t is represented seconds, so that's going to be our x-coordinate when we graph it. Okay, so the things we're looking for, how many seconds will it take for the ball to reach its maximum height? So you're looking for what's the x equal on the vertex. What is the maximum height? So that's your y-coordinate on the vertex. And then we want to give the domain, the x values that it makes sense to have, and range y values. So you got to kind of interpret what it's asking for. So obviously we're going to graph this. We're going to graph it in Desmos, and I want you to look for the vertex. So pause the video, graph it in Desmos, and 1, 2, 3. Alright, so a little hard to read. Here's my vertex, and then we're also going to use these two x-intercepts in just a minute. Okay, so when it asks for how many seconds will it take the ball to reach its maximum height, that's talking about the x-coordinate, because x was talking about seconds, of the vertex. So it's going to take 2.813 seconds to reach its maximum height. What is the maximum height? Height is represented by your y-coordinate, so the maximum height it ever gets to is 126.563. Alright, so domain and range. Domain is like a list of values that make sense for it. So domain are your x values. Notice the ball starts at 0, your x-coordinate, and then it ends when it hits the x-axis or the ground at 5.625. So my domain is going to be, and it's going to look like this. It's a little weird. X is between 0 and 5.625. So it's a range of values. So you're saying your x can be anywhere in between that, because the ball is in the air between 0 and 5.625 seconds. Alright, when I talk about range, I'm talking about my y-coordinates, what it could be. So I definitely have a y-coordinate of 0. Notice those. And then the highest that the y-coordinate gets to is 126.563. So my x values can be between 0 and 5.625. My y values can be between 0 and 126.563. That's my domain and range. Alright, let's do this one. An apple is launched directly upward, blah, 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 blah. You just need to find the equation and understand that x is going to be represented by time and that y is going to be represented by height. So the question asks, what is the height, what is y of the apple after 3 seconds? So when x equals 3. So So if you know that time is 3, you can take 3 and you can plug it in everywhere you have a t. So this is exactly what you're doing. Negative 16 parentheses 3 squared plus 64 parentheses 3 plus 80. I'm replacing the time with the number 3 because I know that the time is exactly 3 seconds. So put that in your calculator and you'll get the answer. So do that. 1, 2, 3. So you get that y equals 128. So at 3 seconds, you have a height of 128. Alright, so you can read this one. It's pretty much the same thing. So here's my formula. Remember, x is represented by time, y is represented by height. How long, so what's the x? How long will it take to reach the ground? And at ground, we would be at a height of 0. So what does x equal when y equals 0? So all you gotta do, graph it and see when it actually hits the x-axis. So go ahead and type this into Desmos in 1, 2, 3. So when you graph it in Desmos, you can see that it's going to take 8.016 seconds for that rocket to come back to the ground. It's just where it hits the x-axis. Alright, let's do some more. Eva is jumping on a trampoline. Her height h at time t can be modeled by blah, blah, blah. Would Eva reach a height of 14? So remember, x is time, y is height. Is it even possible to reach 14 feet? What I would do is I would graph this in Desmos, find the vertex, and see if you ever even reach 14 feet. So do that and pause the video and try it in 1, 2, 3. Alright, so when you graph it and you find the vertex, and remember that you're looking at the y coordinate because you're talking about height, the highest it ever gets is 12.25. So would Eva ever reach 14? No, it doesn't even go that high. Okay, so, and then the last thing we're going to do are the quadratic regression problems. So we talked about these when we did key features of quadratics. You should know by now how to do this in Desmos. If not, go back and watch that video. Or you should know how to do it in the TI-84. If not, go back and watch that video. It was something on YouTube to watch you do it. So we're going to put this into either Desmos or into our TI-84 calculator, and we're going to come up with a curve of best fit. So I want you to pause the video and come up with the curve. And if you don't remember, go back and watch the previous videos because you need to learn how to do it. 1, 2, 3. Okay, so I got negative 16x squared plus 36x plus 50. And then we want to know what is the height, remember that's y, of the coin after 3 seconds. So I'm going to replace the x's with the number 3, because that's what it tells me to do. And I'm going to put those in my calculator. You try it also in 1, 2, 3. And I got 14. So the height is 14 of the coin after 3 seconds. Alright, let's do just one more regression. So once again, here's the table of values. We're talking about the average sale price P of a house in Norfolk, Virginia in thousands of dollars during various years T. Write an equation of the curve of best fit. So either using Desmos or using your TI-84 calculator, I want you to find the curve of best fit. Pause the video in 1, 2, 3. And I'm going to round to 2 decimal places just so I don't have a super crazy looking function. So 2x squared, I'm out of room, minus 12119.64x. And then, holy Lord, 1216817.86. Okay, so now I want to predict the value of the house in 2015. So in our problem, x is representing price. No, I'm sorry, I read that wrong. X is time, and y is price. So predict the value of the house in 2015. So now you know that x equals 2015. So I'm going to replace the x's with 2015, and I'm going to get my answer. So you do it also, and pause the video and try it in 1, 2, 3. Alright, so I got 279.71, and do remember that this is in thousands of dollars. So the actual answer is 2,791,000. So something like that. Okay. So hopefully that made sense. We're also going to do some more modeling problems just because these are pretty tricky and they're a big deal in math. And definitely in Math 2, and you'll see it again in Math 3 and on the ACT. So it's going to haunt you forever if you don't know how to do it. So please reach out and get me to help you. Okay, bye.